Hi guys! So to get started today, we're going to do a little activity, so we just need you to close your eyes and listen and try to figure out where you are, but no cheating, okay? Alright, close your eyes. Alright, ready, and open your eyes. Yay. Did you guys figure out where you were? Yeah? What gave it away? The clicking noises, yeah. So on a roller coaster, this is the Mamba. It's at Worlds of Fun. Have any of you guys ever got to ride on it? Yeah, me too. I just went this summer for the first time actually. So we'll move on to the next slide now. But as you guys may or may not have guessed, we are here to talk to you about roller coasters. So my name is Sarah Wongler. I'm a senior mechanical engineering major at the University of Nebraska-Lincoln.
And I'm Rachel Wagner. I'm also a senior mechanical engineering major at the University of Nebraska-Lincoln.
So what do you guys think makes a roller coaster fun? The speed, yeah, how fast it goes. What else? Yeah, how tall it is, yeah. Yeah, that makes it a lot of fun. Anything else? What do you guys think is the scariest part of a roller coaster? Yeah, loop-de-loops. Yeah, going upside down. It's really fun. It's kind of scary though. So today we're going to talk to you guys a little bit about how engineers design roller coasters. Then we're going to talk about the physics that they use to make sure that they're working. And finally we're going to talk about how different kinds of engineers work together to make a roller coaster.
Alright, starting off with the design of roller coasters, there's a few things that engineers have worked on roller coasters. The first is this anti-rollback device. So if you see on the picture here, this yellow line represents the chain that's used to pull the roller coaster car up the track. And as the chain is pulling the roller coaster car up the hill, you hear a clicking sound like we did at the beginning of the presentation. Well, the clicking sound is actually those blue bars hitting the red triangles. And so what happens is the blue bar hits the red triangles, it allows a safety mechanism to be in place on the hills of the roller coaster. So should the chain ever break, the blue bar would fall back into the red triangles and it wouldn't be able to slide down all the way the rest of the hill, and then the passengers could exit the car safely. So that's an example of how engineers have added a safety device onto a roller coaster. Another thing that engineers design is the brakes on a roller coaster. So we love going super fast like we talked about at the beginning, but at the end of the ride we need to be able to slow the roller coaster car down. And the way that we do this is through hydraulics, and these hydraulics function pretty similar to the brakes on your bike. And the way that they do that is by using the clamping mechanism to slow the roller coaster car down. So they squeeze really tight on the rollers of the roller coaster car, and that allows the roller coaster to slow down at the end of the ride. And then as you can see, the tallest roller coaster in the world, which required a lot of engineering to make it work, is actually 58 feet taller than the state capitol building. So if you guys have ever been to Lincoln, Nebraska, you might have been able to see this building and see how tall it is, and now you understand how ginormous this roller coaster is. Alright, so there are a lot of factors that engineers need to take into consideration when they're designing the shape of the roller coaster track. And you guys should pay attention to this because you might have to do this in an activity later. So the first is that the shape of the first hill and the height of the first hill has to be the tallest throughout the course of the ride. Otherwise, you're not going to have enough energy to carry you through. And Sarah's going to talk about that in a second. So if you remember anything, remember the height of the first hill has to be the tallest. Next, we have the shape and exit path of the first hill. And you need to make sure that that is a safe and fun ride for the riders of the roller coaster. So you don't want an exit path that's super steep that sends them driving straight into the ground, because people could get hurt potentially. So you want an exit path that's still exciting, but it allows the roller coaster passengers to travel safely off the big first hill. Next, the height of the second hill is really closely tied to the height of the first hill. The height of the second hill has to be shorter than the height of the first hill, because the height of the first hill has to be the tallest. And then finally, you have loop-de-loops, and what you need to remember about loop-de-loops is you need to be going really, really fast. And Sarah is going to be talking about why in just a second.
Yeah, so like Rachel said, we're going to get into the physics now. Have you guys all taken a physics class before? No? Okay, that's okay. Physics is just the science that we use to help us make roller coasters. So the first thing we're going to talk about is energy. Do you guys know what energy is? Yeah, right? Okay, so we've got two kinds of energy that we're dealing with on roller coasters, potential and kinetic. So the first is this potential energy, and so that is energy stored. That's how we want you to think about it. So this rubber band, it's pulled back, and once somebody lets go of it, it could go really far and really fast. But it's not moving right now, so that energy is all just stored. Unlike this race car, which is moving really fast, so it's got all kinetic energy. And you can see it's kind of a cycle. You don't just have potential energy or just have kinetic energy, you can have both. So this person standing up at the top of the little diving board here, they've got a lot of potential energy because they're really far away from the ground. But this person who is currently diving has kinetic energy because they're moving really fast through the air. So it's kind of a cycle that keeps repeating like that. And so in terms of roller coasters, the top of the first hill you have all the potential energy you're going to have for the full ride, which is why Rachel said that it needs to be the tallest. So what's important in this equation is the h, that's the height, how high you are off the ground. And so the bigger you make this h, the more potential energy you give yourself. Down here we've got all kinetic energy, and the important part of this equation is velocity, which is just your speed. And so the more speed you have, the more kinetic energy you have. And here you actually have a mix of both potential and kinetic energy because you're off the ground a little bit, but you're not all the way off the ground like you were at the first hill. And you're going kind of fast, but you're not going quite as fast as you were down here. And that's important because on the next slide, I'll show you that all the energy that you have in a roller coaster, it's all the same throughout. So you don't get any extra energy during the ride. So however much energy you start with here is how much you have here and how much you have here. So it's really important that that first hill is the tallest because if you make this hill taller than the first hill, the h is too big and you won't have enough energy to get all the way up it. The next thing we're going to talk about is loop-de-loops. So loop-de-loops are kind of like taking a merry-go-round and flipping it sideways. Have you guys all been on a merry-go-round? Yeah. So what happens when you stand in the middle of the merry-go-round? Yeah, it pushes you out to the outside, right? So that's the same idea with a loop-de-loop. It's this thing called inertia, which basically means you want to continue going whatever direction you were initially going. So like when you're in a car and you turn really fast and you kind of slam into the person next to you a little bit, that's inertia. So the same thing happens with a loop-de-loop because you're going in a really big circle. The inertia actually pushes you back into your seat. And so the faster you're going, the more acceleration you have, the more inertia you have. And by the time you get to the top of the loop, the inertia is so strong that it's actually stronger than the gravity that's pulling you down, so it pushes you into the seat and keeps you there. So even if you weren't wearing your seatbelt, you wouldn't fall out of the roller coaster. We of course still wear seatbelts anyway, just to be safe, but you don't actually need it with the way physics works.
Alright, so now we're going to talk about the different types of engineers who work on roller coasters. And the first type is computer engineers. So a lot of modern roller coasters are actually run by computers, and a computer engineer is in charge of programming and designing the ride. So as soon as the employee at whatever amusement park you're at presses the go button on the roller coaster, the computer engineer's programming kicks in. Next we have the electrical engineers, and they're going to design the electrical systems of the roller coaster. So all the parts of the roller coaster that are controlled by electricity need to have an electrical engineer look at it. For example, those hydraulic brakes we talked about, you need to coordinate with the computer engineer and the electrical engineer to know when to start the brakes. Next, we've got chemical engineers, and a lot of chemical engineers could work with potentially the lubricants on the roller coaster. So if a roller coaster is running over and over and over and over, we don't want it to wear out. So a lot of times a chemical engineer might come up with an oil that we can use to protect the roller coaster so it doesn't wear out as fast. Next, we have structural engineers, and structural engineers work with all of this scaffolding structure that you see on the roller coaster, and they're going to perform calculations and make sure that that is strong enough to hold up the roller coaster passengers whenever against whatever weather conditions you might ever find on this roller coaster. Additionally, you have aerospace engineers, and they're going to work primarily with the profile of the roller coaster car. So like we said, we want the roller coasters to go super, super fast. So that means that our roller coaster cars need to be super aerodynamic so that they can continue to have as much speed as possible. Next, we have the mechanical engineers, and they're going to design things like the hydraulic brakes we talked about earlier on the roller coaster, and those are engineers like me and Sarah. And then finally we have materials engineers. So there's two different types of engineers, two different types of roller coasters that you would see potentially at an amusement park, and that would be a wooden roller coaster or a metal roller coaster. And so a materials engineer would look at the roller coaster design that they have in mind and decide which type of roller coaster material they would want the roller coaster to be built out of. So as you can see, engineers improve the health, safety, and happiness of the world. Thank you.
Thanks, guys. Do you guys have any questions for us? No? Okay, we're going to talk to you guys a little bit about the engineering design process so you kind of know how Rachel and I would think when we're building a roller coaster so that you guys can build your own roller coasters.
Right, so first in the engineering design process, you have to ask the question. And this is a tool that engineers will use to help them define the problem that they're trying to solve. So in this case, you guys are going to be designing your own roller coaster. And so that is the problem that we have given you guys. Next, you're going to imagine all the potential solutions to the problem. So you're going to brainstorm all the crazy ideas, all the cool ideas that you could possibly think of as a solution. And by coming up with as many ideas as possible, there's bound to be a couple really good ones in there. Next, you're going to plan what you're actually going to do. So you're going to weed out some of the crazy ideas that you imagined before. And then you'll take the really good ones and start deciding how you're going to execute them. Then you're going to create whatever you planned. So in this case, you guys are going to create the roller coaster design that you talked about. And then finally, you're going to improve your design. So during the course of this activity, you'll find that your roller coaster might not work as you intended it to work at the beginning, and you'll be able to improve on your design as you continue. So
just to give you guys a little bit more information about your activity, you're going to be getting pipe insulation like this, but we've cut it in half so it makes a nice little track for a marble, which will be your roller coaster car. So you'll get 3 tubes of pipe insulation, you'll get a specific amount of tape that we'll hand out to you, and you'll get 1 marble. If you lose it, you will not have a way to test your roller coaster, so try to hang on to that. And then you'll be in groups of 3 or 4. So the important thing is that you make sure that your roller coaster is freestanding. You can't be holding it up at all. And ask your teachers before you tape on anything, but it's just masking tape, so it should be okay. And you guys can go ahead and get in groups and we'll start passing out supplies.